Yeah, so schedule-wise, we're planning to do a launch pad abort test where Dragon V2 will take off from essentially launch vehicle height. It simulates something going wrong on the launch pad. The astronaut's just about to take off. It's maybe a few seconds before liftoff, and there's a fire on the launch pad. You need to make sure that the spacecraft can fire the Super Dracos, get to a safe altitude, and then essentially take the astronauts to safety. So that test is due to occur later this year. Then next year we expect to do what's called the
in-flight abort,
high altitude abort test. So we launch the rocket. It's at a very high altitude, going very quickly at something called max Q, which is the maximum dynamic air pressure. And then we want to initiate an abort. This is considered one of the hardest times to do an abort. And obviously these are tests, so they could go wrong. But that high altitude abort test is due to occur next year. Conceivably, we could do the first flight to orbit, and we'd initially do it without people at the end of next year. And then the first flight with people in 2016 we think is very achievable.
No animals in between, no monkeys, nothing like that.
I don't think we need to send any monkeys. Now, I'll tell you one funny little quick feature is this. Even with Dragon version 1, we actually do have a moderate life support system Dragon version 1. And sort of a fun thing I think that's happening on the next mission to the space station is that we're going to be carrying 40 mice.
Nice.
So this is how the Mousepreneur mission is going to be happening fairly soon. And then with Dragon version 2, we'll actually test the life support system. So even when it's unmanned, we'll simulate the output of a person. So like the CO2 output and the water vapor and whatnot will all be simulated. So we'll have crash test dummies and that kind of thing. So. But in terms of the first people, I think approximately 2 years from now.
Can you talk for a little bit about the cost? I know it costs about $70 million now for the U.S. to pay Russia to send people out there. What's it going to cost the U.S. now, and also in comparison to the space shuttle missions? Talk about the cost.
Yes, absolutely. So, I mean, I think we're in somewhat of an ignominious situation here where, I mean, it's not merely the fact that Russia is taunting the United States for lack of manned access to space, but they're also massively overcharging. And I think it's gone even above $70 million. I think it's sort of $76 million a seat that the Russians are charging. The quote that we've provided, NASA, would allow the cost per astronaut to be potentially less than $20 million. So it would, and that assumes a low flight rate. So in a high flight rate, it could potentially get to the single-digit millions.
Besides with Russia, does that help you both not only in this case, but with satellite launches, if they're going with home engines to launch?
Well, I think it is. We are in a very questionable situation that a lot of the national security launches being done by United Launch Alliance are dependent upon a Russian engine, and the Russian Deputy Prime Minister has threatened to withhold those engines, which obviously is not a good position to be in. But I think from a SpaceX standpoint, we stand ready to support the U.S. Air Force and intelligence missions with our Falcon 9 rocket. And we look forward to launching a lot of satellites for the Defense Pub and the intelligence agencies, and eliminating that Russian dependency.
Any thawing of relations between you and the Air Force?
Well, first of all, I should say that I think on balance we have a great relationship with the Air Force. I think we have some strong opinion with a few individuals, but with the vast majority of the Air Force, we have very good relations.
How many times is this can potentially go up into space and come back down? I mean, you said that it's reusable. Talk about the future in terms of where your long-term vision for this is.
Well, yeah, so that's a good question. So, I mean, long term, we really want to get to a point where there can be thousands of space flights a year. And ultimately, where we can have a base on the moon and a base on Mars and become a multi-planet species and a true space-rank civilization. So that's where things need to go in the long term.
When you look forward, and for many of us, putting a man on the moon was the ultimate. How far have we progressed since then, and where is this where you saw the future when you started thinking of this project?
Yeah, in fact, I mean, the thing that got me to start SpaceX was that I was disappointed that we'd not made progress beyond Apollo. I mean, there was this incredible dream of exploration that was ignited with Apollo, and it just felt as though the dream had died. And year over year, we did not see improvements in rocket technology. And you know, I kept expecting that we'd send people to Mars, that we'd have a base on the moon, and that the things that were projected in science fiction movies and books would come true, and unfortunately they did not. So I actually, in fact, even before starting SpaceX, I can tell you, like, my goal was to try to figure out how do we increase the NASA budget in order to make that happen. And then as I learned more, I discovered, well, unless we improve rocket technology, it's just not going to matter, because we might do a small number of missions, but that's not the thing that really changes human destiny. The thing that really makes the big difference to humanity's future is, are we a spacefaring civilization? Are we a multi-planet species? That's the thing that makes all the difference in the world, because eventually there will be something that happens on Earth, either a man-made or natural calamity, and you know, humanity's history will fundamentally bifurcate. Are we going to be the multi-planet species that's out there among the stars, or will we be one of perhaps the many single-planet species that never went anywhere, and just eventually something terrible happened and isn't, you know, that caused the end of that civilization?
What is your ultimate dream for space? I mean, what do you ultimately see?
Oh yeah, it helps a little.
Okay, all right.
What do you ultimately see, like, your dream in space? Is it man on, you know, going to Mars, or?
Yeah. So my dream of space is that humanity becomes a multi-planet species, that we have a self-sustaining civilization on Mars and perhaps on the moon and elsewhere in the solar system. And once we have that established, I think over time that would create a forcing function for the continued improvement in spaceflight technology, and eventually we would even go beyond our solar system. I mean, to me that's a really exciting, inspiring future, and it's one to which we should aspire.
What do you think is a realistic timetable for that, for the thousands of flights that you were talking about?
Well, in terms of thousands of flights per year, I think probably 20 years for thousands of flights. And I think we could probably get to the hundreds of flights level in about 12 to 15 years.
What was the biggest technological challenge you faced in this version over the other?
Yeah. So the biggest technology technology challenge for Dragon version 2 was the Super Draco engine, because that's an engine that has to produce a tremendous amount of thrust and yet be very light. It's also got to throttle over a wide range, so it's going to be able to go to a very low throttle range to a very high throttle range. It's going to be able to react very quickly, so that it was quite a tricky thing to develop. But we've actually, we essentially are almost complete with that development. So that's
Can you say how you did that in a couple of sentences?
A couple of sentences, okay.
In a soundbite?
It's really hard to reduce
Entire rocket program.
rocket science to a few sound bites. And, you know, one of the technologies that was really critical to development of the Super Draco engine was the ability to do 3D metal printing. So because it's quite a complex engine, and it was very difficult to form all the cooling channels and the injector head and the throttling mechanism. But being able to print very high-strength advanced alloys, I think was crucial to be able to create the Super Draco engine as it is.
What's the
How
point?
confident are you that it will work? That it will be safe? That it will help astronauts escape safely?
I'm extremely confident in the Super Draco engine. In fact, we've designed it to be super robust.
Is there a reduction of parts count compared to conventional engines?
Yes, there's also, certainly a reduction in cost count for the Super Draco engine because it's printed. And the normal way that you have to make an engine is you have to machine a whole bunch of separate parts and then weld them together, and so that it makes it heavier, less robust, and much more expensive to make. We're actually, so whose 3D technology are we using? We're using actually a variety of printers. We use EOS, SLM, and Concept.
From your low point in 2000.
They're all German, by the way. Germany's doing quite well on the 3D printing front.
From your low point in 2008, did you think you'd be up on the stage today?
No.
Really?
No, I certainly didn't expect. I didn't expect to be unveiling Dragon version 2. Looking back in 2008 when we had we were still only had the Falcon 1 rockets, and we were familiar with the stages, and actually experienced the third consecutive failure of our little rocket. Fortunately, touch wood, things have worked since then.
Nice.
But man, that was a super low point, and I would never expected to be up here on stage talking about version 2 of our spacecraft that can dock with the space station.
But what does this mean? What does this day mean to you personally, as somebody who grew up inspired by Apollo, that you now are the one that are doing this?
Well, it's really difficult to comprehend. I mean, I find this a very unexpected circumstance.
At Temple, you have so much going on. Reusable rockets. Do you have to go to the public market? Are you going to have to go public?
Well, with SpaceX, fortunately, we are a positive cash flow, and we have been for several years. So we don't have to go public. And unlike in the case of, say, Tesla and Solar City, SpaceX has a very long-term mission. We want to just keep improving rocket technology until there's a city on Mars. And well, that could take a long time. And I think the public markets, I suspect that is beyond their normal time horizon.
Yeah. Will Dragon V2 carry cargo in the trunk?
Oh, so how many flights can Dragon 2 fly without any refurbishment? We're aiming for 10 flights without any significant refurbishment. And then the thing that would have to be refurbished is the main heat shield. But that remains to be seen. This is the heat shield material is called PKX version 3, which is a thermal-impregnated polymer layer version 3. With each version, we've been able to reduce the amount of recession that occurs in the heat shield. You can think of the heat shield like it's a giant brake pad, basically. And the better that material technology gets, the more uses it can go through. And just like a brake pad on a car, eventually it does need to be replaced, but I think that we can eventually get up to maybe 100 flights or something like that.
Will this version carry cargo in the trunk?
Yeah, so we're aiming for, in terms of reuse, what really matters in terms of the reusable elements of a vehicle is that it has to be rapid and complete. So we want this to be able to fly the same day, so it should be able to arrive and depart the same day.
Elon,
otherwise it's not rapid.
why do you think, Elon, Elon, why do you think you're the only person doing this? You're making the electric cars, you're sending these up, hopefully to Mars one day. Why are you the only one?
I'm trying to get back to my home planet,
No, but I mean, is it your vision, your what makes you carry through these projects? I mean, in America, or in the world.
Well, I think, first of all, I'd say in America it's probably the only place that where this would be possible, for a private company to get this far. And we've been able to attract an incredibly talented team at SpaceX. We've got a brilliant team of engineers and technicians that really did the design and construction of this spacecraft, and I think having that critical mass of talent is really what's enabled me, if you can call it me. It's not really me. It's other people, but I think having that critical mass of technical talent is what has enabled us to get this far.
And capital. Right.
Yeah, and capital, certainly. I mean, in the case of SpaceX, I think something that was very helpful was coming out of PayPal. Coming out of essentially the internet arena, I had a bunch of capital that I could spend developing rocket technology, even though I had no experience in rockets at all. And if I try to get funding from, say, a venture capitalist for that, well, that would have, they would have been angry that I met with them, probably. Even in the best of circumstances, space is outside of the comfort zone of most venture capitalists. Although, sort of a few years, I think like 4 or 5 years into, 5 years, I guess, after starting the company is when the first sort of venture capital came in. We had some good partners there, and then, about 5 or 6 years after the start of the company, we also started getting some support from NASA, and actually, in the last several years, NASA has really been crucial to our success. In fact, this is something I should have mentioned on stage, is that we really would not be where we are today without the help of NASA. That's an important acknowledgement.
And is this emotional?
NASA contract this summer. What happens to Dragon 2's development program?
If we don't win on the NASA contract, we'll do our best to continue the development and still make it happen.
This is notoriously an unfriendly state for business, an unfriendly county for business.
That's not that bad.
California.
I don't personally expect to leave California. Certainly, there are probably things California could do to make it easier to manufacture and do things here. But I think overall California has a lot to offer. I think the biggest thing about California is it's got a lot of really talented people. So as long as the talented people are in California, I think California will do okay.
Dragon was led from Dragon 1, and perhaps what happened on the last mission we had, did you have any lessons?
Well, in terms of lessons learned from Dragon 1, there's certainly a lot that we learned in every aspect of the vehicle. Whether it's the heat shield technology, the engine, the breakaway engine technology, orbital maneuvering, deorbit and trying to achieve a precision re-entry path through the high velocity entry. That's quite a difficult thing. So although Dragon version 1 lands with parachutes, it actually, before the parachutes open, it actually is executing a very precise guided path with the engines firing during re-entry.
Will Dragon 1 remain in production to continue to carry cargo, or will it be phased out in favor of V2?
Over time, we expect Dragon version 1 to be phased out, but we're going to carry both of them in parallel for at least a few years.
Yes. You recruited in front of E3 for people, and I was wondering.
Yeah, sure. I think I'll try to answer any questions I can, but I'm happy to shake that.
Elon, you recruited in front of E3, and I was wondering what the gaming prowess, people who've worked in the gaming industry, what do they bring to this type of project?
Sure. Actually, something that's worth noting is that a lot of what is needed on a rocket or spacecraft is actually software. We actually hire a lot of our best software engineers out of the gaming industry. And in fact, for myself, I started off when I was a kid. In terms of engineering, I wrote games. That was the thing that I did. So I think.
What's special about gaming?
Well, I think in gaming, there's a lot of smart engineering talent doing really complex things. In fact, if you think about a lot of the algorithms involved in, say, a multiplayer online game, compared to a lot of the math that's involved there, doing a docking sequence is actually relatively straightforward. In fact, I'd encourage people who are in the gaming industry to think about, joining SpaceX and creating next generation spacecraft and rockets, and also probably, in the future we'll create like droids on the surface of Mars and Moon to do things like an automated propellant depot and that kind of thing. You sort of need those features to have a base on Mars.
When you got out of this,
let me just say hi to someone here.
Hi. How much longer?
A few more minutes.
Start this one.
So Elon, when you came out of this, you looked like you got a little emotional. Were you feeling, like what were you feeling? When you walked down the stairs, you kind of... yeah.
I think I was just feeling really proud of my team for creating such an incredible piece of technology, and also just it felt like maybe here we have a shot to advance space technology and take things to the next level. I mean, to some degree, maybe this helps revive the dream of Apollo.
Can you talk? Because you're making it cheaper, is that the ultimate goal here?
Well, cheaper is one way to say it. I mean, another way to say it is like really, we're trying to make space accessible to everyone. We want it to be such that if you want to go to orbit or beyond, that you can do so. We want to open up space for humanity, and in order to do that, space must be affordable.
Can you talk a little bit about the BFR and the MCT just a little bit? Give us a little heads up.
Oh my God.
I think today is not about.
I get it.
Not about those, but there'll be some future stuff.
So you're talking about space tourism?
When will I go up? Well, it's certainly tempting to go up soon. I used to do lots of like things that were personally risky, but now with kids and responsibilities, I do a lot less of that. So I used to have like a fighter jet and do all sorts of crazy stunts, and I was like, well, I want to see my kids grow up and all that, and then I have responsibilities. So I think I'll probably be, a couple years after the first astronaut crew goes up, maybe 4 or 5 years, I suppose. If the first crewed flight is in roughly 2 years, then I'd probably go up a couple years after that.
Can you talk a little bit about the splashdown of the CRS-3 first stage out off in the Atlantic? And what you've learned from the telemetry and the video you might have gotten back?
Oh, yes. As far as the soft landing of the boost stage.
Yes.
It was interesting, like when we got the corrupted video back, because we really actually had a real difficult time getting the telemetry. In fact, I'll say a funny thing. We actually had to, because normally we get the telemetry from a boat.
Right.
And then we also had a backup, like an Navy P3 that was going to go on.
Yeah.
And the P3 got iced up. The boats couldn't go out. So I actually had to. I sent my plane up with my pilots, and we had to design and fabricate an antenna that exactly fit in the window of the plane.
Nice.
So we started off with a pizza dish, and we're able to do like a double-loaded antenna with a pizza dish.
Nice.
Pointed out the window to get the thing.
How about the decoding of that corrupted file? How's that going?
Yeah, so we got the data came through really well, but the video was corrupted because unfortunately when you compress video, it's actually hard to uncorrupt a compressed video because you actually have to figure out the compression algorithms.
Right.
So we weren't able to get very far, but we put the video online, and then we sort of crowdsourced the cleanup of the video, and the people did a really great job of fixing it. And I actually tweeted out a link to the latest thing, and it was a bunch of people on the NASA Spaceflight Forum that were able to fix the video.
Well, that's pretty cool.
Yeah.
Will this one land on land?
Yes, this will land on land. In fact,
Chris, that's for you.
Quite a bit like the video you just saw. So we want to try to land this back at Cape Canaveral, ideally. Initially, we may land it, somewhere else, but it's all the nominal mission landing. So unless it's an emergency, all the landings will be on land.
Can you tell us about
Do you know a bit more about that and where the
Oh, yeah, there was a little bit of water ingress from So because it got dragged a bit through the ocean, so there's a pressure relief valve that it got some water. But from my understanding, none of the cargo was damaged, so it's okay.
Elon, you mentioned the heat shield was made out of, say that word again.
Yeah, so
and how is it better than what NASA's used and what other heat shields that are in use?
Right, so...
But say the name of that again, I didn't
Yeah, the heat shield material is called PICA-X.
PICA? P-I-C-A?
PICA-X, and it's version 3. So it was initially actually developed at NASA, the original version of PICA.
Stardust.
And it's, yeah, exactly, for the Stardust mission. And it's called, essentially, phenolic impregnated carbon ablator. And it's the highest heat flux material known to man. So
NASA developed it. These guys improved.
This can take more heat than any other material that anyone knows about. And as pointed out, it was specifically developed
for Stardust, interplanetary.
Exactly, for the Stardust mission, which is coming in from interplanetary velocity, and it was coming in at such a high speed that normal heat shield materials would not work. So they had to develop something new. So then we started with that as a baseline and created a variant of PICA called PICA-X version 1. And then with each successive mission, we've experimented with improvements on the heat shield material. So we're now up to version 2, and we'll be flying version 3 on Dragon. Version 3 of the PICA will be on version 2 of Dragon.
Nice.
Yeah.
What did you add to this to make it better?
Actually, I can't talk about the details of technology because it's protected by ITAR.
Right.
And what are the top temperatures and speeds?
So the let's see, it can take essentially 7 passengers. If it's in the crew configuration, it can take 7 passengers, and I think something around, if you really cram stuff in there, about a ton of pressurized cargo and 2 to 3 tons of unpressurized cargo.
Who flies in the first version 2?
The first version 2, the first crewed version, I think, will be determined by NASA. I think it'll be...
Really? No SpaceX test pilots then?
It really... we will defer to NASA in terms of the first people on board.
Sounds good.
So if NASA wants us to fly SpaceX test pilots, we'll do that. Otherwise, we'll fly NASA astronauts.
Will the V2 carry trunk cargo, like the Dragon 1 does?
Yes.
They will carry trunk cargo.
They'll carry trunk cargo, yeah.
What are the top temperatures and top
Actually,
speeds?
can carry probably up to about a ton of internal cargo, too.
Excellent.
What are the top temperatures and top speeds it's going to sustain? What are the top temperatures and top speeds it's going to sustain? Don't mess with Jersey.
Well, there's the temperatures that will sustain, and then there's the temperatures that it could sustain. The proper way to think of a sort of heat shield material is in sort of watts per square centimeter. And then there's the peak heat flux and the sustained heat flux. So, the PICA-X version 3 is capable of over a kilowatt per square centimeter, which is a crazy
That's a lot of heat.
Yeah.
Wow.
And sustaining that for quite a while. In fact, it's really driven by the, not by the recession rate, but by the conduction of the heat to the back of the tile, where it can then potentially damage the heat shield support structure.
So can you give a top temperature and a top speed?
Good luck.
Top temperature. Well, I can estimate that pretty...
That this is going to hit, that the Dragon's going to hit.
I'd say 5,000 or 6,000 degrees Fahrenheit, something like that.
And top speeds? It'll hit?
Well, top speed, it's going to be coming in at roughly 25 times the speed of sound.
Okay.
That's sort of reference point. It could probably handle twice that kinetic energy, maybe more.
Elon, did you...
Or is it an engineering model?
Most of what you see is light hardware. Yeah.
Elon, I apologize if you already answered this. What is the price of this? And is it $20 million per seat? And how much should it, how much does it cost to produce the spacecraft itself?
I'll give you some precision with respect to the costs. In terms of what we've bid, it is contingent upon flight rates. So if you assume, let's say, 4 flights a year, touchscreen, and there are 4 of them in the vehicle. Is actually two pairs of 2, I should say. The great thing about them is you can configure the interface to have a wide range of controls and a wide range of feedback. And you can really have almost infinite amount of information that you can access and any amount of control that you like with a touch screen. As anyone who's used an iPad can attest, I mean, the range of things you can use in that is really unlimited. And then just in the unlikely event of all the screens being destroyed, the critical functions can all be controlled with manual buttons. So, in terms of manual shoot, deploy, and reserve oxygen going to the backup system for any kind of life support, that stuff can all be controlled with manual buttons.
So are you using Tegra SoCs to power the graphics on there? Or are you using NVIDIA technology to power
We actually, we will be using Tegras to power the screens.
Also, are you, now...
The Tegras power the screens, but not the spacecraft.
Right.
Yeah.
But are you, NASA wants to get a spacecraft up to the ISS from America by 2017. Are you going to be ready on that date or sooner?
Yes, from a SpaceX standpoint, we actually expect to be ready to transport crew in 2016. It's about a year sooner than NASA needs it. So I think NASA wants to be a little bit cautious about the timing of things, so that they don't want to count on us being there by 2016. But we feel fairly confident that the vehicle will be ready in 2 years.
Has anyone else approached you to use your technology? Any private space stations, any other private companies that want to use Dragon besides taking it up to the ISS?
Well, Bob Bigelow, I guess he's here somewhere, I believe.
Okay. I'll ask him.
What was the development cost of the vehicle?
Oh, for Dragon spacecraft? You mean including version 1 and everything, or just version 1 to version 2?
Probably version 1 to version 2.
So far it's probably been $400 or $500 million, and it'll probably be that amount more to get through to first flight.
What percentage?
Something on the order of $1 million.
What percentage will be privately funded versus government funded by NASA?
For the spacecraft itself, it's going to be probably something on the order of 70 to 80% NASA funded. But for the rocket, it's not NASA funded at all. So development of Falcon 1, Falcon 9, all of that that's 100% private. So if you say like what's the total development that's been for including the rocket and the spacecraft, I think it's probably something closer to 50-50 NASA and private.
I see SpaceX actually replacing NASA.
No, we're not replacing NASA. NASA is our most important customer.
In the future, what do you think?
No, I think there's always a role for NASA. I think there's always going to be things that where there's no obvious way to commercialize something. Think of something like, say, the Hubble telescope or the James Webb, or some of the exploratory probes that go to Mars and elsewhere. It's always going to be important for NASA to be doing those things because there's no obvious economic model for
Do you think
those
you can
things.
find investors for that?
No, I don't think we can find investors for
basic research.
An investment means that there's an expectation of return. That's good for a donation, but
I can think of some.
What led to the decision to use 3D technology?
First of all, I think anything if you can 3D print something with sufficiently good material properties, then that's the easiest way to do it. It's certainly in the volumes of a rocket company. It's harder to make that work for the same car company. But in the case of the Super Eco engine, we didn't in the very beginning anticipate being able to 3D print it. We actually tried a whole bunch of sort of normal methods of making the engine, and actually those did not have great success. And then we said, well, let's give this sort of 3D printing a try and see if it would work. But initially we thought of it as somewhat of a Hail Mary on the Super Eco, and it actually turned out to work super well. Yeah.
Are you planning?
Next launch? Yeah, I think that we're just double checking everything in the rocket, and we expect to probably, I think we're at June 10th or something like that. Yeah, thereabouts, yeah. So.
What was the problem?
We had a helium leak. The helium is a pernicious little molecule, I have to say.
Yes, it is. Any thought to getting past helium at some point?
So here I'll give you sort of a tidbit on the sort of Mars vehicle, which will be methane powered.
Right.
The Mars vehicle will be autonomously pressurized with methane and oxygen. So instead of helium pressurization of the power tanks.
No helium on Mars.
There's no helium, exactly. There's no helium on Mars. So we'll gasify the liquid oxygen and the liquid methane to pressurize the respective tanks.
Nice.
Yeah. Looking forward to that.
Fully reusable?
Yes, absolutely.
Really?
All right, a couple more questions and then I'll have to bail out.
How do you improve the radiation resistance versus the first version?
Well, you know, for any kind of low Earth orbit activity, you're still essentially protected by Earth's magnetic field, so the radiation danger is not super great, particularly for a short flight. We have improved the micrometeorite shielding. So when you see the shielding on the outside, it's actually doing a lot of things. It's helping protect against high velocity. There's alpha particles coming from the sun, and any kind of high velocity sort of molecules coming in. It's obviously protecting against the heat re-entry, and then it also has to be a micrometeorite shield. So we improved the micrometeorite, so the shield, it's got better shield.
Yeah.
You had a reset on the COTS, on the CRS-1 mission, I think. Is there some changes to kind of protect against that?
Oh, you're talking about the electronics?
Yeah,
absolutely.
Bit flips.
So bit flips. In fact, even with Dragon version 1, typically Dragon version 1 is like version 1.3 right now, arguably. In that the avionics of Dragon version 1 have gone through two major revisions. And on the last flight we saw no sort of anomalies with the electronics at all. There were no bit flips that weren't automatically and instantly corrected by the system. So it's, we certainly learned a lot, and I think, although it's obviously not really visible because it still looks the same from the outside, the electronics on the Dragons flying now are much more advanced than the first one.
Elon, you said that you were going to defer to NASA on people to fly Dragon, but you have an astronaut on your staff, so why not, and I forgot his name, but why not use him?
Garrett Reisman.
Well, NASA is our customer, really, with Dragon version 2, so...
Oh, okay.
It's up to them.
It would be like, if somebody buys a Model S and we're not going to be the ones who say who drives it. If you buy the vehicle, you get to say who's on it.
Do you plan on selling them to NASA for them to use, or do you plan on operating them on behalf of NASA?
These would be operated on behalf of NASA.
On behalf of NASA.
Is NASA your primary source of funding?
NASA is our single largest customer. But if you look at the missions on Manifest, the NASA missions are, I think, 20 to 25% of our missions on Manifest. So roughly a quarter of our missions are for NASA.
Can you talk about your commercial launch site in Texas, how that's going?
In fact, I think the FAA just recently, maybe even today, gave the approval for the Texas launch site. So we're pretty excited about building that out.
Right.
That's going to give us redundancy for any eastward launches. So,
Can you reach the space station from Texas?
Yeah, absolutely. We can reach space station from Texas, yeah.
Excellent. Are you planning on moving any manufacturing there?
I shouldn't say, we would only do so in emergencies. The default path for the space station would be 39A most likely.
Right. But you can reach it from Texas if you had to.
Yes.
Yeah.
And we can actually reach it from, I think, Coolharder, but maybe from Vandenberg too.
Really?
The real coast of it, yeah.
Do you plan on utilizing Vandenberg more in the future? I know you've only launched once there so far.
Yeah, we'll actually be doing a lot of missions from Vandenberg. So, for example, the Iridium constellation, the new generation Iridium constellation will be launched from Vandenberg, and that's, I think, at least 8 missions.
Excellent.
Yeah.
Is there any plans to launch Heavy from Vandenberg?
Yes, we expect to launch Heavy from Vandenberg as well.
Excellent.
And although it does look like the first Heavy, we originally thought the first Heavy might go out of Vandenberg, but it's now looking like the first Heavy will probably go out of the Cape, in fact, from 39A.
Okay.
So, all right, well, thank you, everyone. Appreciate you coming, and I hope you had a good time.
Thank you, Elon. Autograph? These are of Cassiope at Vandenberg.
Oh, cool.
I live right next to it, so...
So you, Garrett, and I were at Penn at the same time.
Yeah, no kidding, really?
Yeah, and it's nice to see two of you actually doing something with your life.
Get that one, too.
Yeah, it's funny. It was like friends of mine went back for like a 20th reunion. No, I mean I've been back. I've got a couple of talks at that, but
like a completely different.
And if you don't mind, there's one more inside too.
Okay.
It's inside the folder.
Yeah, it's a nice shot.
Yeah.
It's a tall rocket, eh?
It's a very tall rocket. It's much skinnier than anyone thought it was going to be. It's very impressive.
It's actually it's as skinny as I thought we could possibly make it. We stretched it to like as long as.
Why so thin? Is it for road transport or is it for?
Yeah. Essentially, it's 12 feet in diameter, and then when you add like little bits and pieces, it gets out to. Well, almost 14 feet.
Right.
And then we have to tuck the little bits and pieces in the corners. Because the key thing is that the total height above the road has got to be less than 14 and a half feet.
Right. For bigger rockets, how are you going to move those around then? Because clearly you can't boat.
Well, they're going to fly themselves.
Right. Well, hey, I appreciate it.
Roads, that's for sure.
Exactly. Well, thank you very much, sir. Appreciate your time.
Any chance?
That'll get a lot of money on eBay.
That's not what it's for.
The sort of the hard points where the tanks and the parachutes and everything are mounted. There are these basically these vertical blades that transfer a load from the to the pressurized section. So that's one of the factors, and they don't quite line up. So we'd either have to sort of add a lot of mass to have them really be symmetric, or we can have them not be symmetric and not add extra mass. And then the other thing that's important is that if the parachutes are deployed, the parachutes, like you see these sort of strange lines that are...
Those are the shroud lines, aren't they?
Yes.
Yeah, okay.
Exactly. So the parachutes, the main parachutes are over here. It's behind the Dragon thing is where the main chute is. And then the drogues are on the top. And you can see that those lines basically go from where the drogues are to the mains. And so where it's held, where the parachute line attached is just above where the hatch is, and so it actually comes in at an angle.
Right.
So another thing so it'll be coming in due to wind drift. If it's got lateral velocity, it'll be coming in. And you want the load to be taken out by the legs. So you don't want it to land on one leg. Right. Because then one leg's going to take too much load. So having two legs together, closer together, actually helps that too. So it sort of takes the initial impact on those two rear legs, and then onto the
Will the Dragon Fly vehicle? The Dragon Fly vehicle you're going to fly in Texas, is it going to be based on this configuration? The one you're going to fly in McGregor?
Yeah.
It's going to look a lot like this then.
Yeah, look almost identical.
Excellent. And the high altitude abort vehicle?
It tends to be a lot smokier, with like more scorch marks and stuff. But yeah, pretty much look like this.
Okay. Well, thank you.
So yeah, I'm really looking forward to it. It should be fun to just see it hop around pads.
Excellent.
So, all right.
Bye bye.
Photo of you.
Any picture of you inside? Can we get a picture of you inside? Can we get a picture of you inside?
It'll be.
I'm glad to see two of you doing something with your life.
So you're saying that Elon said that yeah, he's going to defer to NASA to see who flies it first.
Yeah, so I mean, the rule is that at least one of the crew on the test flights has got to be a NASA astronaut.
Okay.
Now it's up for interpretation whether or not the other crew members are NASA or they're SpaceX or a combination there.
Right. Do you think it's going to be like a taxi model where like a SpaceX astronaut will ferry people up, or?
When we're flying regularly.
Yeah.
I'm just talking about the test flights.
Okay. Yeah. I'm just kind of big picturing right here.
When we're flying regularly, it's a rental car. So
it's a what crew?
It's a rental car.
A rental car. Okay.
So it'll be all NASA astronauts.
All NASA astronauts, and the test flights are going to be SpaceX and NASA or some combination.
Or it could be all NASA. So it's one or the other.
But you don't think that they're going to sell them directly to NASA, and then it's going to be hands off from that point on. So SpaceX will always have some control or responsibility for the vehicles at all times.
Oh, we'll run mission control, and we'll be controlling from the ground. And, but we're not going to have anybody inside.
Right.
Other than the NASA astronauts.
Okay, that's cool.
Turn and smile. There you go.
There you go.
So,
what do you think of this?
It's nice to meet you, because I knew there was like it's sort of nice to meet 10 people who are not in business.
So compared to shuttle, what would you think about the V2 here?
Oh man, well they're very, very different. I mean, V2.
Oh, clearly it's a totally different class of vehicle. So
yeah, it's totally different. But the thing about V2 is it has the potential to be a lot safer than shuttle.
Yeah, you can abort at any time during flight, right?
You can abort at any time. That's something the shuttle couldn't do.
Clearly.
It's got a very robust design for entry. It can sustain a number of failures and still be safe.
Yeah.
The shuttle was a wonderful, wonderful vehicle, but it was very
fragile.
Yeah. It operated very close to the edge of its operating envelope. So.
Elon mentioned.
How is this different than the standouts between this model and the previous one for you?
Oh, I mean, Dragon V2 and V1?
Yeah.
Oh, the biggest differences are the Super Draco engines, so that we can do a launch abort, but also, like Elon said, a propulsive landing. And there's a lot of other more subtle differences, but I think that's the biggest one. Well, I guess the other biggest one I'd say is that this one can dock to the space station all by itself. It doesn't have to be grabbed by the space station robot.
Will that be controlled by the astronauts inside to actually run the docking internally, or will it be done by the guys on the...
It's going to be nominally, it's going to be automatic, so if everything's going well, it's going to do it all by itself.
Okay.
But there'll be the capability of the crew to take over if they need to.
Is there a simulator for this? Have you tried it? How does it compare to the shuttle?
It's kind of similar. We do have a simulator, and it is basically flying into the space station feels the same in Dragon as it did in Shuttle.
Excellent.
Yeah.
Will they do the short duration rendezvous like the Russians do, like the 6-hour rendezvous?
That's what we'd like to do. Yeah.
That's gonna be awesome.
Yeah.
You trained in the Soyuz, right?
I trained in the Soyuz. Yeah.
How does it compare to the Soyuz? That's what I was
Oh man, there's so much more elbow room in there compared to the Soyuz. Plus, you could take, instead of just bringing 2 of your buddies, you can bring 6. So there's a lot of advantages over the.
How many times did you fly in Soyuz?
It's got modern electronics. It's got modern materials and a heat shield. I mean, just technologically speaking, it's a giant leap beyond Soyuz.
Propulsive landings, do you know where they intend on landing it initially, or is it gonna... I know Elon said the first ones are gonna parachute into the water like V1 did, but when you start doing land landings...
Our very first V2s are gonna come down on land.
They're gonna come down on land. Okay, do you know where?
They have the capability as a backup to come down in the water in an emergency.
Right.
But yeah, we have a couple places picked out where, but I don't want to get ahead of Elon. Let him tell you where.
Totally cool.
Now, what do you do? What is your title here, and what do you what are you in charge of?
I'm the program lead for this vehicle, for the Crew Dragon, the crew vehicle. So I'm the program lead for that, and I'm also our capture manager. So I'm in charge of our proposal team that's working on with NASA for the next phase of commercial crew.
Excellent. You guys go through orals yet with NASA?
Yes, we have.
And I'm curious, next phase of CCT cap, do you think there should be one? Should they down select to one, or should they retain competition?
I think, frankly, it's in NASA's best interest for there to be more than one.
Absolutely. Yeah.
You always want to have a plan B. The nation's best. Yeah. Now, just got to convince Congress to pay for it. That's all.
The House, especially.
Especially.
Yeah.
Well, guys, I got to head off.
Hey, thanks a lot. Nice to meet you.
Thanks so much.
Nice to meet you. Take care.
You too.
Yay, red and blue.